today we're going to be discussing the address operator as well as the reference operator and indirection operator. Again, we have another example of the address operator down here. And then we are finishing our program with the reference variable that we just discussed. These are all separate videos that I've completed. They will be in the notes if you haven't already watched them. However, this is going to be a quicker recap just to give you an idea of when you see an ampersand sign inside of your program, you know what it's doing. So again, let's go ahead and discuss our first example. So our first example is going to be this number one address operator. And as we can see inside of memory, so if we're going to, and again, I created a more in-depth video about this. However, if we're going to display this in memory, we see that we have an integer data type named number in memory, which is assigned 10. So it's assigned 10. And again, it's going to be equivalent to 4 bytes because it's an integer. So we have these bytes inside of this box inside of memory. And that's what's coming down and getting this memory is this ampersand sign in front of the variable name that is getting the address of the variable. So that is why it is called the address operator. For my second example, you can see the reference operator and indirection operator. Again, we're starting with an integer variable just for example purposes. Integer name of variable assigned to, again, equivalent to what we just saw inside of memory. However, when we come down here, we come down to a pointer to an integer, and that's exactly what this is doing. And you can also go ahead and point it in front of the variable name. However, that's not usually advised, but whatever floats your boat. So again, so we have a pointer to an integer, and then we have the variable name, and then we have our assignment operator. And then this is where the different ampersand sign comes in place, because this is going to be containing the address of number, like what we just saw up here. So this is containing the address of number in memory. However, this assignment is allowing a pointer to point to the address of this variable. And that's because it has the ampersand sign in front of it. It is assigned to it, and it's a pointer to the same data type as the variable that is trying to be used. When we come down here, if we just want to see what it looks like in memory, we can, and that's what we see. The number in memory is here, this long hexadecimal number. As you can see, it's a different number than what's displayed up here if you look closely. So then I come down to my dereference operator. So my dereference operator is just showing you what is inside of my first pointer, and it's just name pointer. Again, ridiculously long name. It's usually PTR, but whatever. So we go down to the dereference operator. So my first pointer contains, and then this is what we would call the dereference operator or indirection operator, depending on your preference. And it's going to be listed in front of the variable name, as you can see in my cout statement. However, if I wanted to reassign that pointer and that initial variable to something else, I can do that by using the indirection operator, again, or the dereference operator, followed by the variable name and assigning the value to something different. So when I come down to my two cout statements, as you can see here, my first pointer contains 2. And then now, that's because it contains 2 up here. So my first pointer contains 2. So technically it's containing 2 right here until it comes down here to line 28 and it gets initialized to 10. Therefore, number is also changed to 10 and first pointer is changed to 10. And that is what is being displayed here. And as I come down to my reference variable, it just looks like I use the same number. So I'll go ahead and print a different number for that. All for my third example for the reference variable, I want to show you I was showing you the wrong ones. I should have been showing you these for the pointers. However, I'm going to go ahead and change the value of the reference example just so it's not confused with these pointers. So as you can see, again, my first pointer in here contains 2 because 2 is assigned to number, and the first pointer is initialized the address of the number variable itself. So it points to it. And then as we can come down here, we can see it inside memory using the address operator. And then I'm going to come down to my dereference operator to display what is inside of my first pointer. And it's 2 because it's initialized to 2 until it comes down to line 28, where first pointer with the indirection operator or dereference operator, however you want to specify that, it comes and changes the pointer to 10 itself. And then again, the original variable is now assigned 10 because it contains the address of that variable, that initial variable. So going back to the reference variable, so I don't get you guys confused, I'm going to go ahead and reprint this and display this information for you all. So it will display 12s now at the bottom instead of 10s, because that was a lot of 10s. For some reason, I was 10 happy. Okay, so going into the reference variable, it's going to be kind of similar to the pointer. However, it's just references. So again, so I'm starting out with an integer variable named ref example, which is assigned 12. Again, that's at 4 bytes. It contains the number 12 in there until I come down here and I come to my reference variable. And similar to the pointer, except for this is a reference variable, it's going to be referencing an integer data type. And again, it has a name, new ref example, which is assigned this variable name. So similar to our pointer here, we have our pointer, which contains the address of number. This is just a reference variable pointing to an integer data type, but it's going to also update whatever is inside of this ref example. As you can see, if I go ahead and display this, so then now we just have 1212 right now because it just contains 1212. However, if I was wanting to change new ref example and change it to 14, I can do new ref example and then do the original ref example just to show you. I'm just doing it on one line differently this time. And then now as I display it, it's going to display 1212 and then 1414 for those last 4 numbers. As you can see, 12, 12, 14, that's because when it did the reassignment of the new reference example, because it is a reference variable to this initial variable, it's going to change the value inside of this variable. If you like this video, please like, share, subscribe. I'm sorry I had to do a quick video today. I went to the weekend, I had the time of my life. I always feel like work hard, play hard. I'm also keep preparing for school. I hope everybody has a great day. Thanks for your time.